Hello, Pandemic Pre-Calculus, and welcome back. In this video, we're going to talk about zeros and something called their multiplicities. So first, I just want us to take an example and take a look at this graph that we have here. So let's give ourselves a nice example to work with so we can understand this idea of multiplicity. So let's look at the function f of x is x plus 3 times x minus 2 squared times x plus 1 to the third power. So what's nice about this equation is it's already factored for us. So if we want to find the zeros of this function, we could just set each of these linear factors equal to 0. X plus 3 equals 0. X minus 2 is equal to 0. X minus 2 squared, is equal to 0. And x plus 1 cubed is equal to 0. And then we can solve each. Negative 3 here, 2 here, negative 1. And so we know that we have zeros at negative 3, negative 1, and positive 2. So these are our zeros for this function. The graph is going to behave differently. Not just the graph of this function, but the graph of a function can behave differently at different zeros. So we have 3 zeros here, and our graph is actually going to do something slightly different at each 0. So it can behave differently at each 0. So what I'm going to do is go over to the graph on Desmos, and we're going to look at each of these zeros, and we're going to look at the behavior of the graph, and that's going to help us understand a little bit more about what a multiplicity can be. So here's actually our graph. I'll show you the equation. We have x plus 3 times x minus 2 quantity squared times our x plus 1 cubed. And we can see that we have the x-intercepts exactly where we would expect them to be. This is where our zeros are on the function. But something slightly different is happening at each one. So let's zoom in on the graph. Let's make it a nicer shape. Look at how I'm stretching that graph. All right. And I'm going to call up each of these points here. So take a look. Let's mark this up. Here at the point, negative 3, 0, the graph is going straight, it's almost linear. It's not a perfect line. I want you guys to know it's not a perfect line. But the graph is just cutting through the x-axis in a way that seems almost linear. Now let's take a look at our point, negative 1, 0. That graph is crossing through the x-axis in kind of this S shape almost. A lot of people call it an S, a curve. There's this nice little curvy shape. And then for this point here, our graph is bouncing off of the x-axis at that point. So we have 3 different behaviors. At negative 3, 0, the graph is crossing through almost like a line in red there. At negative 1, 0, the graph is crossing through the line, but with this curve shape. And at 2, 0, the graph is bouncing off kind of like a quadratic, a little bit like a parabola, like those parabolas that we graphed. So let's take a look again at the equation. We had that equation was f of x is equal to x plus 3 times x minus 2 squared times x plus 1 cubed. And I'm going to highlight each piece of the graph in each part of the equation in the same part that the graph is. So this is where we got our 0 in green. This is where we got that part of the graph highlighted. This is where we got that part of the graph highlighted in blue. And this is where we got that part of the graph highlighted in red. So what I want you to notice here is that where the graph is cutting through in a way kind of like a straight line, the factor that gave us that 0 has an exponent of 1. Where the graph is bouncing almost like a parabola, almost like something quadratic, the factor that gave us that 0 has an exponent of 2. And where we have this sort of little curvy shape here, the factor that gave us that 0 has an exponent of 3. So multiplicity, multiply, what multiplicity is really talking about is that we have factors that are repeated. And at each of these repeated factors, we have a different way that the graph is going to behave. So let me erase this and I'll show you again what I mean by repeated factor. A repeated factor. Let's get rid of some of this here. Because there's another way that I could have written this function. I can write this function like this. I could say x plus 3 to the first power times x minus 2. I didn't give myself enough room. Terrible. Let me do it again, guys. Sorry. I just want to make it neat so that you can take some nice notes so we can talk about it in class. We could write f of x is equal to x plus 3 times x minus 2 times x minus 2 times x plus 1 times x plus 1 times x plus 1. So what I did there was I took that negative 2 squared and I expanded it. So here's where we had the negative 2 squared. And notice how that factor is repeated twice. It's repeated twice. Where we had this curvy spot, that factor is repeated 3 times. I expanded that. And where we had the almost a straight line but not quite, that factor was repeated only once. Excellent. So there's a pattern here that can really help us when we're trying to determine the shape of a graph. And it has to do with this idea of multiplicity, of repeating the factors. So where I repeated the factors twice, I had that behavior we highlighted in green. Where I repeated 3 times, I had that behavior that I highlighted in blue. And so what I want to do now is I want to change our function a little bit, and you'll see that the behavior is actually going to change. Let's get rid of this. Let's look at our original function. So here is our function. Here are our zeros. So what I'm going to do, where it says x plus 3, I'm going to change this and raise our x plus 3. Instead of raising it to the first power, I'm going to square it. And watch what happens to our graph. One thing is going to change about our graph. Whoa! Look at this. So notice here, my -1, 0, the behavior of the graph there stays the same. Around 2, 0, the behavior of the graph stays the same. And now at -3, 0, my graph is acting like a parabola. So when it has a power 2, it's acting a little bit like a parabola. Let's look at it. Let's try if we get to the power 3. What happens if I make this a power 3 and hit enter? Look at that. Now it has that same curvy shape. This is still acting like a quadratic. This is still acting like a curved shape, and this has now changed to join it and be also a curved shape. So let me show you guys something really nice we can do here. I'm going to give us a really good example. So we're going to say f of x is equal to, let's say, x minus 1. And then we're going to raise that to some power. We're going to raise that to some arbitrary power. Let's call it a. I'm going to add a slider for a. I'm going to make the smallest value for a 1. And the largest value for a, I'm going to make that 15. So this is a way for us to change our multiplicity. So the 0 of this function here is at 1. When I plug in 1, it makes the function 0 right here. And I'm going to push play on this A, and it's going to change our power. So first it's going to raise it to the second, to the third, to the fourth, and so on. And I want you to watch what happens at our intercept, at our 0 here. Watch what happens. So what I notice is our 0 stays in the same place, but what's happening at the 0 changes. It almost looks like it's waving at you, doesn't it? Doesn't it look like it's waving? So when my multiplicity is even, when it's 14 or 12 or 10 or 8 or 6, my graph at the 0 is bouncing off, just like it does for the quadratic. It bounces off. And when my multiplicity is odd, when the exponent on this factor is odd, like at 3, 5, 7, 9, 11, what's happening there is that my graph is actually crossing over at that multiplicity, or at that 0, when I have an odd multiplicity. So that's really what you need to know about multiplicities. The multiplicity tells you about the behavior. Let's write this down. We saw some good observations there. Some of you are probably like, huh? It's okay to watch it again. It's okay to ask a question in the comments. It's okay to ask your classmates on the discussion board. But I'm going to summarize what we just saw here. So when the multiplicity of a 0 is even, the graph bounces off the x-axis at that point. When the multiplicity of a 0 is odd, the graph crosses through the x-axis at that point. This will help you when you're trying to graph polynomial functions because you'll be able to find the intercepts fairly well. You can find those by using your calculator, by factoring. So you'll be able now to find those zeros and also to know what the graph's doing at those zeros. That's going to help you graph. I hope that helped. Thank you for watching. I hope you guys stay safe out there. And I will see you in the